Hello everyone, welcome back to my channel. In this video I will show you the first method to get CP2K, which is to download the precompiled executable sopt and ssmp from CP2K official website. So if you go to the website and scroll down, basically this sentence says that if we want to get the precompiled version, we need to go to the GitHub page and then scroll down. In the release, there you are. That's the sopt version. This is the ssmp version. You could just download that. It is a single file. And then we have already downloaded that. Not here, but here, yeah. Basically this. Then I will just show you one simple calculation and do a benchmarking. This is a single point calculation for silicon crystal. I will go into detail later, but this is the basic set, this is the pseudopotential, and this is the input file. I will not go into detail now, but basically this is a DFT self-consistency calculation of silicon crystal. Yeah. Okay. So we first try the sopt version, which is the single core serial version. We need the full path to CP2K. And sopt, and then we can copy the rest of the command and then rename the output file to be sopt. This would be the usual command that you use for the calculation, but now I would add the time before so that it can show how much time the command uses. And usually afterwards we can use this sign to make it run in the background so it does not occupy the terminal. But here we just leave without that so that we know when it ends. And then we start the calculation. This should be fairly fast. Okay, and you see basically three numbers. The real number is the total time for the command to run. Basically, is the end time minus the start time. The user time is the CPU time. For single core execution, the real time is quite similar to the user time. We just copy the real time, just to take a note, yeah. And then we add a note here. And then let's try to use this ssmp version, which offers OpenMP support. And that's basically the command here. First, you need to export the number of threads that you want to use for OpenMP. And here I use 6 thread because I have 6 core CPU. If you are not sure how many CPUs you have, you can go to ls CPU. And then that there are 6 cores, yeah. You can do some tests, but usually I find it more efficient if we use only 1 thread per CPU. Yeah, so now I just use 6 cores. And then we could do the calculation ssmp and then change the output name accordingly. You see that the real time decreases. The reason is that now we use multi-threads to do the calculation. So user is the total CPU time, which is more or less real multiplied by the number of threads that we use. So real multiplied by 6. But of course there are some discrepancies because of some overhead. But you see that now the real time is much faster, yeah. To get some statistics, maybe we want to do it again to see whether it is consistent or not. Yeah, you see that now it's 2 seconds, probably this is because of some overhead. So this you have to keep in mind if you are doing some benchmarking. Just make sure that you do it multiple times to see whether it is consistent, yeah. And this is more consistent than this now, because 2 multiplied by 6 is more or less 12, yeah. Here this is one sign that this parallel computation works, and another sign is that if you go to the output file, you will see that number of threads for this process is 6, yeah. And this is the ssmp output. If you go to the sopt output, you will see that the number of threads is 1, yeah. So this is a single core calculation. Okay, so in this video I've shown you that you could very easily download the precompiled executable from the official website, and then the ssmp version already offers you multi-core support that increases efficiency quite a lot. Yeah. In the next video, I will show you the second method, which is to use Package Manager to get the MPI version of CP2K. So thank you for watching. If you learned something from my video, I appreciate your like or subscribe to my channel, and I hope to see you next time.